Hello, am I audible? Hello, 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 hello. Yes, I think Prisha has not joined yet. Yeah, Prisha is here. Yeah, first of all, I'm sorry that we had to end our last class abruptly. There was some technical issue at my end. I'm sorry once again. Uh, we were in the middle of discussing problem sheet number 16, and we have 17 as well pending. We'll see that, but before that, I would like to go to the next concept. Okay, I would like to go to the next concept, and then we'll come back to these problems. Okay, so the next idea is about we are going to see equations and inequalities which involve the modulus operation. Okay, the modulus operator. I'm sure you're familiar with the modulus operator. Okay, you've seen this simple modulus of x. So what does modulus operator or what does modulus operation or modulus simple? Okay, what does it give? Can somebody tell me what does it give? What does what does modulus of x give? Yeah, it gives the absolute value. I mean, it gives the value of x without the sign. Okay, so it gives the non-negative value of x without the sign. Hope you have seen this. I hope you have seen this before. Please let me know. Others, Prisha and Robin, can you tell me whether you've already seen this? Yeah. Robin, have you seen this? The modulus operation in school. Have you come across this modulus operation? Robin, are you with me? Are you with me? Yeah. Okay. Cool. Cool. So, say for example, modulus of 3 is going to give you 3. Okay. And modulus of minus 3 is also going to give you 3. Modulus of 3 gives you 3. Modulus of minus 3 also gives you 3. So my question is, if somebody is telling you that mod x is equal to 3, this is an equation. What will be the solution to this equation? If somebody is telling you modulus of x is equal to 3, modulus of x is equal to 3, what will be the solution? Solution means the value of x that will satisfy this equation. What will be the solution to this equation? I hope my question is clear. If somebody tells you mod x is equal to 3, mod x is equal to 3, what will be your x value? What will be your x value? Think well. I would like to get an answer from all of you. Yeah. What about others? I've got 2 answers so far. Yeah, it's plus or minus 3. And what about Robin? Could you give me an answer? Somebody is telling you mod x is equal to 3. For some x value, modulus of that number comes out to be 3. So what will be that number? Okay. So the answer is x is equal to plus or minus 3. So if you put x is equal to 3, that will be satisfied. If you put x is equal to minus 3, that will be satisfied, because for both 3 and minus 3, the absolute value is nothing but 3. We have seen this already. So Prisha, I hope it's clear for you now. There are two solutions. It's plus or minus 3. There are two solutions. It's plus or minus 3. Okay. Now, I'm going to discuss something very abstract. So please listen very carefully. This idea is very simple, but you should be convinced about this thing. So modulus of x is nothing but x itself when x is a positive number. Okay. Modulus of x will be x itself when x is a positive number. That is clear, right? When x is a negative number, your mod x will be minus x. Why does that make sense? See, the first part is clear for you, right? First part is clear. When x is a positive number, mod x is nothing but x. You don't have to do anything. You don't have to do anything at all. Yes. But when x is negative, what happens? X is already a negative number. So you have to put a negative minus sign outside to make it positive. Okay, in the second case, whenever x is negative, you have to put an additional negative sign to extract its magnitude. See, for example, if your x is minus 3, you know that your mod x is 3. And this number is nothing but negative of minus 3, which is negative of x. Hope this is clear. So you should understand this fact clearly. Whenever x is positive, there is no confusion. Modulus of x is simply your x itself. Because it's already positive, you don't have to do anything to get its absolute value. But when x is negative, you have to put an additional negative sign so that the number will be its corresponding positive value. Hope this is clear. Yes, please, others, please let me know. This is a very important thing. Okay, this is a very important thing. So idea is very simple. Whenever your x is a positive number, when x is a positive number, your mod x is nothing but x. When x is a negative number, your mod x is minus x. Now, looking at this, you should not get confused. You must be wondering, mod x is never negative. So how can you put a negative sign there? Can mod x be minus x? Can mod x is equal to minus x? Yes, it can. When x is already negative. If you put an additional negative sign, that is going to give you the absolute value, right? When x is already negative, modulus of x will be negative of x. Yes, I hope this is clear. I would like to get an answer from Robin as well. Please let me know. We have seen that example as well. When your x value is negative 3, your mod x is 3, and that is nothing but minus of minus 3, which is 3. Robin, could you give me an answer? If it's confusing, please let me know. I'll be able to explain once again. Robin, are you with me? If it is confusing, please let me know. Oh, okay, cool. No issues, no issues. Yeah, cool. I'm sorry. Yeah. So again, let's see what is the geometrical interpretation of the absolute value. Okay. So we have our number line here. We have our number line 0, 1, 2, 3, 4, 5, -1, -2, -3. Okay. So we can think of the absolute value of a number as its distance from 0. The absolute value of a number may be thought of as its distance from 0. So if I tell you modulus of -3, what is the meaning of this expression? This can be thought of its distance from 0. So we have -3 here, we have 0 here. So when you calculate the distance, this is going to be 3. The distance is going to be 3. Got it? So modulus of x can be thought of distance of x from 0. Whether it's positive or negative, distance will always be a positive number. Irrespective of whether x is positive or negative, your distance will be a positive number. Hope this is clear. Yeah. So that is about the modulus operation. Let's see some questions, very simple questions. Let's see some very simple question. So what will be the solution to the equation modulus of 2x is equal to 8? What will be the solution to the equation modulus of 2x is equal to 8? Simple equation. We'll be seeing only very simple equations, okay? And we'll also see simple inequalities. Yeah. So modulus of 2x is 8, which means what? Your 2x is going to be 8 or -8. It's 8 or -8. So 2x is equal to 8 means your x is equal to 4, and 2x is equal to -8 means your x is equal to -4. So the two solutions are plus or minus 4. Okay, the two solutions are plus or minus 4. The two solutions are plus or minus 4. Okay, I'll give you another question, another example. We'll see another example. Modulus of x minus 3 is equal to 6. Let's take 5. Modulus of x minus 3 is equal to 5. Can you tell me what will be the solution to the equation? Modulus of x minus 3 is equal to 5. Modulus of x minus 3 equal to 5. Can you tell me what will be the solution to this equation? Take some time, no problem. Prisha and Anjali, please recheck your answers. Modulus of some quantity is equal to 5 means what? That quantity is either 5 or that quantity is minus 5, right? So this means your x minus 3 is 5 or your x minus 3 is minus 5. So this means your x is equal to 8 or your x is equal to minus 2. Hope this is clear, Anjali and Prisha. Hope this is clear. Make sense? Yeah. Now you can actually go back, substitute and check your answer. Just plug in 8 in this equation. When you put 8, 8 minus 3 is 5. When you take the modulus, it is 5 again. Again, if you go and substitute minus 2 here, when you put minus 2, what happens to that? Minus 2 minus 3 will be minus 5. And when you take modulus, it is going to give you 5. Yes. Cool. Let's see one more question. Modulus of x minus 3 is equal to 3. The modulus of x minus 3 is equal to 3. What is the solution? Modulus of x minus 3 is equal to 3. So what do you think will be the solution to this equation? Yeah, right. You can check your answer yourself. How can you do that? You just plug in the values to the equation, back to the equation and see that it is true. Yeah. So what do we have here? We have modulus of some quantity is equal to 3, which means that quantity is either 3 or minus 3. So your x minus 3 is either 3 or your x minus 3 is minus 3. Or so your x value is either 6 or your x value is 0. You can go back to this original equation, substitute the value and verify that it is indeed a solution. Got it? Let's see another question. Modulus of 3x minus 7 is equal to 8. Modulus of 3x minus 7 is equal to 8. Yes, okay. So we have 3x minus 7 is equal to 8, or 3x minus 7 is equal to minus 8. So we have 3x is equal to 15, x is equal to 5. Or we have 3x is equal to minus 1, x is equal to minus 1 by 2. So there are two solutions, 5 or minus 1 by 2, right? And make sense. So this is not a tough thing, okay? We have already seen linear equations. Now modulus, if you have any equation that involves modulus sign, you are going to get a pair of linear equations. That's all. Okay. But the thing is, it's or, which means both of them will be solutions. Let's see another question. Modulus of x is equal to minus 3. Modulus of x is equal to minus 3. What will be the solution here? Modulus of x is equal to minus 3. Just think. If I tell you modulus of x is equal to minus 3, yes, that's right. Absolutely right. There is no solution, because there is no number on the earth that will give you an absolute value of minus 3. Absolute value of any number. You take any number on the number line. The absolute value is not possible. It cannot be minus 3. Okay? Can never be minus 3. Absolute value of x cannot be minus 3. It cannot be minus 3. It cannot be minus 3. Got it? So this has no solution. No solution. Modulus of x is equal to minus 3 is never possible. No solution. Got it? I hope this is clear. Let's see one more question. Hope this is clear. Modulus of x is equal to minus 3, so it's not possible. What about Olivia, Robin? I hope it's okay. Yeah. Let's see another question. Modulus of x is equal to 0. Modulus of x is equal to 0. What will be the solution? Yes. 0 is the only solution. 0 is the only solution. 0 is the only solution. Got it? So we have seen different cases. Okay, we have seen a variety of cases. Now let's see how we can deal with inequalities involving modulus sign. Let's see how we can deal with inequalities involving modulus sign. So I'll give you a simple inequality. Just think of the solution. Try to represent it on the number line. Okay, because I've already given you the geometrical interpretation of modulus. Let's see. Modulus of x is less than or equal to 3. modulus of x is less than or equal to 3. Can you just take some time, think about it, okay, and try to come up with a solution set to this inequality. Modulus of x is less than or equal to 3. Okay, what about others? Just try to interpret it geometrically as well, because I've already given you the geometrical meaning of modulus of x. The geometrical meaning of modulus of x is the distance of x from 0. Distance of x from 0 is less than or equal to 3. So what does it represent on number line? Think of it in that way as well. Yes, very good, very good. So let's interpret it geometrically. Listen carefully. So I've told you that this modulus of x, what does it represent? This represents the distance of x from 0. You couldn't put the line under which, meaning you didn't put equality. That's what you're saying, right? Instead of, okay, yeah, distance of x from 0. So mod x represents the distance of x from 0. Okay. So we have the number line here. We have the number line here 0, 1, 2, 3, 4, 5. This is minus 1, minus 2, minus 3, minus 4. Okay. Now, what does it represent? Modulus of x represents the distance of x from 0. So it means that distance of x from 0 has to be less than or equal to 3, which means the maximum distance of x from origin from 0 has to be 3. So x is within a distance of 3 units from 0. X is within a distance of 3 from 0 in both directions. So 0 in the right direction, towards the right direction, 3 units will be here, and in this direction it will be here. Now, if you choose your x value in this interval, if you choose your x value anywhere in this interval, its distance from 0 will be less than 3, less than or equal to 3, right? You choose your x here. So you choose your x here. Distance from 0 is just 1 units. Clear? But if you choose your x here, if you choose your x here, the distance from 0 is going to be 4 units. That's not possible, because distance of x from 0 has to be less than or equal to 3, which means the maximum value of the distance from origin has to be 3 units. So 4 cannot be an answer. What about minus 4? What if I choose minus 4 here? Again, that's not possible, right? Again, that's not possible, because from minus 4 to 0, it's a distance of 4 units. That is not possible. So our answer is simply your x value will lie between minus 3 and 3. Your x value lies between minus 3 and 3. Your x value lies between minus 3 and 3. X value lies between minus 3 and 3. Clear? Now, what does this mean? You take any number in this interval that will satisfy our inequality. So you can verify that. You can actually verify that. You take some number between minus 3 and 3, any number between minus 3 and 3. When you plug that in the question, that should be satisfied. The original equation inequality must be satisfied. So you take, say, for example, minus 2. You take x is equal to minus 2. You take x is equal to minus 2. Modulus of x becomes 2. And mod x is less than or equal to 3. That is right. Your 2 value is less than or equal to 3. Similarly, if you take, say, some number like 1. Take some number like 1. We took minus 2 here. Take some number like 1. You substitute it here. We have 1 less than or equal to 3, which is a true state. Got it? Yes. I'll give you another example, another question. Mod x is greater than or equal to 3. Mod x is greater than or equal to 3. And by the way, just give me a minute. By the way, if you had something like this, mod x is less than 3, what would have been the answer? If I had something like this, mod x is less than 3, there's no equality sign here. What would have been the answer? The answer would have been minus 3 less than x less than 3. Clear? 3 and minus 3 will not be included. 3 and minus 3 will not be included. 3 and minus 3 will not be included. Got it? Got it, got it, got it. Yeah, okay, cool. So what about this question? If I have modulus of x greater than or equal to 3. Just think of it for some time and come up with the answer. Take your time, no problem. Mod x is greater than or equal to 3. What will be the answer? No, what does it mean? You are, when you write minus 3 greater than or equal to x greater than or equal to 3, what does that mean? What does it mean? We don't usually write it this way. This means that your x is greater than or equal to 3 and your x is less than or equal to minus 3. And we don't use that notation. You know, when you have a compound inequality, When you represent it this way, it simply means and. Okay. See, please listen carefully. Please listen carefully. In the previous example, when you write minus 3 less than or equal to x less than or equal to 3, what is the meaning of this expression? This is a compound inequality, and this means that your x value has to be less than or equal to 3 and your x value has to be greater than or equal to minus 3. Both these conditions needs to be satisfied. Both these conditions need to be satisfied. X is less than or equal to 3 and x is greater than or equal to minus 3. That is the meaning. Right? You understand what I'm saying? When I write minus 3 less than or equal to x less than or equal to 3, it simply means that your x is less than or equal to 3. And the second statement is minus 3 is less than or equal to x. Minus 3 is less than or equal to x means what? X is greater than or equal to minus 3. So they are connected by an and. And means what? They should be satisfied simultaneously, together. Okay. You understand this point? You understand what I'm saying? In the previous example, when we are combining these two inequalities, it is understood that they are connected by an and, which means both of them has to be satisfied simultaneously, which means your x has to be between 3 and between minus 3 and 3. It has to be less than 3 and it has to be greater than or equal to minus 3. X has to be less than or equal to 3 and it has to be greater than or equal to minus 3. Now, when you write this, see, some of you have given me this answer. This, when you write this actually doesn't make sense, because x is greater than or equal to 3 and the second condition is x is less than or equal to minus 3. Right? So this doesn't make sense. How can your x be greater than 3 and less than minus 3 simultaneously? How can your x be greater than 3 and less than minus 3 simultaneously? You understand my point, right? So this is a bad notation. This is a wrong notation. Okay. You understand what I'm saying? This is a bad notation. This is a wrong notation. Because it means your x is greater than or equal to 3 and your x is less than or equal to minus 3. Which doesn't make sense because your x cannot be greater than 3 and less than minus 3 simultaneously. Okay, this doesn't make sense because this is going to give you a null set, no solution. This means no solution. What you actually meant was you wanted to choose all numbers on the right side of 3 and you wanted to choose all numbers on the left side of minus 3, right? That is what you meant. Am I right? What you wanted to write was on the number line, what you wanted to choose for the numbers which are on the right side of 3 and the numbers which were on the left side of 3. Am I right? You wanted to choose all those numbers and you wanted to choose all those numbers. Am I right? Yes or no? On the number line, you meant these numbers are the solutions, right? Yes. In the previous classes, we have seen that this should be represented as two sets. These are two individual sets of numbers. So this set of numbers represent x greater than or equal to 3 and this set of numbers represent x less than or equal to minus 3 and they should be connected by an OR. So what does that mean? What does it mean when they are connected by OR? It means what? It can be either in this set or it can be in this set. Okay. When you connect it with an and, it means both the condition needs to be satisfied. Both the conditions need to be satisfied simultaneously. So remember this. Have you learned about sets? Union of sets? Union and intersection of sets? Have you heard of union and intersection of sets? In school, have you learned about sets? Set, set and its operations, union, intersection. Okay. Do you recall? Yes or no? Do you recall sets and their operations? There is union A union B, and there's A intersection B. Do you recall this? You may have come across this in grade 8 or grade 9. I'm not sure which grade. Yes. Others, do you remember? Do you recall coming across sets and their operations? So basically, this means you have a set of numbers here. You have a set of numbers here. You're going to take the union. Okay. You're going to take the union of these two sets. You're going to take the union of these two sets. Okay. But when you write and, it means intersection. You have to take the common part. Got it? So the solution set to this equation, somebody tells you mod x is greater than or equal to 3. What does that mean? It simply means the distance of x from origin. Distance of x from 0 has to be greater than or equal to 3. Distance of x from 0 has to be greater than or equal to 3. So on the number line, they will be represented like this. You take all numbers beyond 3 to the right side of 3. Okay, take any number to the right side of 3. Say for example, you take 4. It will be satisfied. So this is one case. Another case is you take all the numbers beyond -3 to the left side of -3. Say for example, you take -4. You take -4. Modulus of -4 will be 4. 4 is greater than or equal to 3. So that is also a solution set. So there are two sets here. There are two sets, okay, and they should be connected by a union or an or. So we write x is less than or equal to -3 or x is greater than or equal to 3. Okay. You can also write x is less than or equal to -3 union x is greater than or equal to 3. But writing this is a wrong practice. Writing this way, your x is greater than or equal to 3, -3 greater than or equal to. This is a wrong practice because usually when you combine two inequalities, we mean and. Okay, so try to write it this way. Do not write this way. It's a wrong. I mean, it's a bad practice. It's a bad practice. Got it? Let's see one more question. We have modulus of 2x less than or equal to 6. Modulus of 2x less than or equal to 6. Can you tell me the solution to set to this equation? Modulus of 2x is less than or equal to 6. we have an inequality here. So it is going to be a range of numbers. Yeah, take your time, no problem, no hurry. I mean, we are going very slow because I want to make sure that your concepts are very clear. There should not be any gaps or misconceptions or things like that. Of course, you would have seen all these things in school, but we have to be very clear with the concepts. Uh-uh. No. Here we have modulus of 2x less than or equal to 6. Yes, that has to be the right notation. Olivia. No, it is not 6 there. Prisha, it will not be 6 there, it will be 3. I think you made a typing mistake. And Olivia, the notation we will use in this case will be, yeah, what Prisha and Anjali has written. See, in this case, please listen carefully. Again, please listen carefully. We have some quantity is less than or equal to 6. Okay. So if I have x is less than or equal to 6, you know that this simply means your x has to lie between minus 6 and 6. So what does that mean? If I had this kind of equation, what does that mean on the number line? On the number line, the numbers will be between minus 6 and 6. Okay. You take any number between minus 6 and 6. Sorry, modulus of x will be less than or equal to 6. Modulus of x will be less than or equal to 6. Okay. And it is represented in this way. Minus 6 less than or equal to x less than or equal to 6. In this case, it's just one continuous set of numbers. This is one continuous set of numbers and it will be represented in this way. Remember when we had two sets, we used OR. Here it is represented in this way. It means what? Your x has to lie between minus 6 and 6. I hope that clears your confusion, Olivia. I hope that clears your confusion. When you have a single set, continuous set of numbers, you can represent in this way. It simply means that you're taking all the numbers between minus 6 and 6. Okay. Yeah. Now, instead of x, we have 2x here. Instead of x, we have 2x here. So it means that your 2x has to lie between minus 6 and 6. Okay. Your 2x has to lie between minus 6 and 6. Now you can deal with you can get rid of 2 by dividing it with 2 everywhere. Okay. Since it's a positive number, we don't have to worry about the inequality flipping. Okay. Since it's a positive number, we don't have to worry about the inequality flipping. So divide by 2 on both sides. We have 2x by 2 less than or equal to minus 6 by 2 less than or equal to 6 by 2. So we have x less than, so minus 3 less than or equal to x less than or equal to 3. This means that all numbers between minus 3 and 3. This means that all numbers between minus 3 and 3 on the number line. Okay. The other case was different. In the other case, we had a set of numbers where your x was greater than or equal to 3, another set of numbers where your x was between less than minus 3, and they were both solution sets. So in that case, we combined it using an OR. Okay, let's see another question. Let's see another question. We have, say, modulus of 2x greater than or equal to 6. Modulus of 2x greater than or equal to 6. Can you tell me what the answer will be? Take your time, think about it. Take your time, think about it. No hurries. Absolutely no hurries. Again, I told you, please refrain from using that notation, because that doesn't make sense. Okay, please listen here. Please listen carefully. If your question were this kind, mod x greater than or equal to 3, if your question was this kind, mod x greater than or equal to 3, how will you do it? It simply means that distance of this represents distance of x from origin. So distance of x from origin is greater than 3 units, which means what? Which means what? It represents numbers greater than or equal to 3, or it could be numbers less than or equal to minus 3. Okay, this is the solution set, right? So this is the solution set here. So we write this. So the solution set is actually union of two sets. One set is x greater than or equal to 3, or the other set is x less than or equal to minus 3. So this is how we represent it. This is how we represent it, because we have two sets here. We have two sets here. That is how this is how we represent. Prisha, I hope the confusion is it still confusing? See, when you have two sets, Okay, you have to combine them using an OR, because it means what? Any number greater than or equal to 3 or any number less than or equal to minus 3 will satisfy that condition. Okay, so usually we don't write this way. This is a bad practice. We don't write minus 3 greater than or equal to x greater than or equal to 3. We usually don't write it in this way. I mean, it's a bad practice. It is better to write it this way. Okay, usually we don't write this. It's a bad practice. But in the other case, we could have easily written this way. See, in the other case, we'll simply write this because it's just one set going from minus 6 to 6, or it's just one set going from minus 3 to 3. But in this case, you have to understand that there are two sets of numbers. One set of numbers goes from 3 to infinity, I mean to the right side of 3. Other set of numbers goes from minus 3 to the left side of minus 3. So there are actually two sets of numbers. To understand that, it is better to represent it in this way, okay, and not this way, because it's confusing. Writing this is confusing. So don't write this way, represent it this way. Okay, it's always better to write this way. This is a bad practice. Okay, now coming to our question. In our question we have modulus of 2x is greater than or equal to 6. Modulus of 2x is greater than or equal to 6. So this means that your 2x is greater than or equal to 6, or your 2x is less than or equal to minus 6. Got it? Your 2x is greater than or equal to 6, or your 2x is less than or equal to minus 6. Now you get rid of 2 by dividing it with 2. So you have x is greater than or equal to 3, or x is less than or equal to minus 3. So this is our solution set. I hope that is clear, because this represents two sets of numbers. This represents two sets of numbers. Got it? Let me know. The idea is clear, right? The notations, the idea is very clear, right? I mean, you have done this in school. This was covered in your Algebra 1. But you must be very thorough with the concepts. There should not be any confusion. Okay? You should have crystal clear concepts. All right, let's see one more question before we wind up. Suppose we have some question of this sort. Suppose somebody tells you mod x is less than or equal to minus 3. Suppose somebody tells you mod x is less than or equal to minus 3. Don't jump directly into the solution. Just think of it. Just think of this expression. What does it even mean? What does this even mean? When you have mod x is less than or equal to minus 3, what does that mean? Does that even make sense? How can absolute value of something is less than minus 3? So what do you think will be the solution set? What do you think will be the solution set? What do you think will be the solution set to this inequality? Mod x is less than or equal to minus 3. Somebody is telling you that mod x is less than or equal to minus 3. Is that even possible? Absolute value of a number is less than or equal to minus 3. Is that even possible? Absolute value of number is less than or equal to minus 3. Is that even possible? Can absolute value of a number be less than or equal to minus 3? No. The absolute value of a number can never be negative. The absolute value of a number can never be negative, let alone less than minus 3, right? It cannot be less than minus 3. It cannot be less than minus 3. Absolute value of x cannot be less than minus 3. So there is no solution. No solution. No solution. No solution. Just quickly, can you tell me what will be the solution set of this this inequality? Somebody tells you modulus of x is greater than or equal to minus 3. Somebody tells you modulus of x is greater than or equal to minus 3. What do you think will be the solution in this case? Yes, very good, very good, very good. Others. Modulus of x is greater than or equal to minus 3. What does it even mean? You take the absolute value of a number and the question says it has to be greater than minus 3. Of course, it is satisfied by all real numbers. It is satisfied by all real numbers. So the solution set is going to be the entire number line. Okay, all real numbers, or you can say all real numbers, all real numbers, all real numbers. Got it? Why does it make sense? If you take the absolute value of any real number, it will always be positive, greater than or equal to 0. So when somebody is telling you that absolute value of x is greater than or equal to minus 3, it is satisfied by all real numbers. You understood the concept, right? What is the meaning of a solution to an inequality? It is a set of all numbers that will satisfy the given inequality. In this case, somebody tells you that modulus of x is greater than or equal to minus 3. This condition is satisfied by all real numbers. So the entire real number line is the solution set. Got it? Cool. Make sense? Okay, what I'll do is I'll share a problem sheet based on our today's discussion. Of course, there are past problem sheets that is pending for discussion. I'll definitely do it in the next class. Okay, so I'll share a sheet with you. Thank you, and we'll meet again in the next class next week.